Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So we have an original amount, and this represents 100% of the original amount. The new price, new amount, represents 113% because it has said that it has gone up by 13%. So it has increased by 13%. And as a value, that increase is £1,287. So it's 13% of the original. It's gone up 13% of the original price. So what we're going to do is we're going to work out what 1% of the price increase is. Instead of 13%, we're going to work out what 1% is. And we're going to do that by dividing the amount by 13. And we get 99. So 1% represents £99. So 1% of the original represents £99. But the new amount is 113%. So we need to times the £99 by 113, which gives us £11,187. So the picture is now worth £11,187. So we can see that the first four of these have already been plotted. Now it's really important that you you do the coordinate the right way around. So the first one is number and then algebra. So we're looking at this coordinate here. We're 18 on number, which would be here, and then 14 on algebra, which would be this point here. 12 on both, so 12 and 12 would be here, and then 21 and 17. So 21 and 17 would be roughly there. So the first piece of information I'm going to focus on is the fact Denver gets 8/19. Denver gets 8/19. That means that Engel and Fido together must get 11/19 because they have to add up to 1. So we're only looking at 11/19. I'm going to focus on the ratio next of Engel to Fido. So it's 9/5. And let's have a look and see, well, first of all, how many parts there are all together. So 9 plus 5, which is 14 parts. So there are 14 parts in total, and the share that they get is 11/19. So what I'm going to do is to find out what fraction one of those parts is worth by dividing 11/19 by 14. So each part is worth, and I'm just going to keep this into my calculator, 0.041 blah blah blah. And we're asked to find Fido's share. Well, Fido has 5 parts. So Fido has 5 parts, each of them worth 0.041 blah blah blah. I've kept it in my calculator to keep the accuracy. And when I do that, I get 0.206 blah blah blah. Now we're asked to work it out as a percent, so I'm just going to times that by 100. So we have 20.676 blah 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 percent, and it wants it rounded to the nearest percent, so that would be 20%. Or actually, it would be 21% because this would round it up, so 21%. So there's a formula for percentage increase or percentage change, and it is the change over the original amount times 100%. So to find out the change here, we're going to do the difference between 1,421 and 1,100. So we're going to do 1,421 take away 1,100, which is 321. Divide that by the original amount. So the original amount was the 1,100, and then times by 100%. And that's going to be 29.18%. To find the exterior angle of any polygon, we do 360 divided by the amount of sides. These are decagons, which means they have 10 sides. So the exterior angles will be 36 degrees. And the exterior angle is just an angle that kind of continues on. You just continue on from the side. So this one here is the exterior angle of the left-hand decagon, and this one here is the exterior angle on the right-hand decagon. So altogether, the angle A will be 36 plus 36, which will be 72. So our answer will be 72 degrees. The most important first thing that we do is whenever you square something, you times it by itself. So we're going to rewrite this as x minus 15 times x minus 15. And then the way we approach this is exactly the same as we've done with the other ones. We're going to do a multiplication grid, and we're going to do x minus 15 at the top, x minus 15 at the bottom, then we're going to do x times x, which is x squared, x times minus 15, which is minus 15x, same again here, and then we've got a minus times a minus, which is a positive 225. Put all the terms together. Now you can see here that we've got the x terms here that will add together. So that would become minus 30x plus 225, and that's actually our answer. So it's x squared minus 30x plus 225. So we're looking for angle DEC, which is this one here, but we can't go directly there. We've got to kind of work our way towards it. And the first thing I'm going to look at is these set of parallel lines here. And we've got a line going through these parallel lines, which is this line. If I try and do it without removing it, this line here. And so therefore this angle here and this angle are going to be corresponding. So this is going to be 69 degrees. So I need to write that down properly. So angle CDE equals 69 degrees because of corresponding angles. Okay. So if I know that the CDE is 69, I also will know that this angle here is 69 because they're the bottom two angles in a triangle. Now, when I say that, I mean when an isosceles triangle is the right way up, the bottom two angles are equal. So they're the bottom two angles in an isosceles, although the isosceles is on its side here. And we need to write that down. So it would be angle DCE equals 69 degrees. And this time it's because it's an isosceles triangle. And finally, we can work out what CED is by taking those away from 180. So angle CED, or actually I should keep it as it says in the question, DEC, is equal to 180, take away the 69 plus 69. And the reason for that is angles in a triangle equal 180 degrees. And when you do that, you get the answer of 42 degrees. So the answer is 42 degrees. There's a lot going on with this question, so I'm going to start off just having a look at the total amount of money. So I'm going to do this in pence, so 2,115 pence. And if each merit point is worth 3 pence, then we can work out the amount of merit points by doing 2,115 divided by 3. So that gives us 705. So there's 705 merit points. Next, have a look at the question here, this part here, where it says James has X merit points. Sarah has 4 times as many points as James, so she's going to have 4x. Robert has 69 fewer merit points than James, so he's going to have x minus 69. And we know that that equals 705 because we've just worked that out. And this feels like a solving coming on. So we've got x plus 4x plus x, which is 6x. Minus 69 equals 705. And we're going to add 69 to both sides. So we've got 6x equals 774. Then we're going to divide 6 both sides. And so we've got x equals 129. So x equals 129. That means James has 129. Sarah has 4 times more, so she will have 516. And Robert has 69 fewer, so we're going to take 69 away from that, and that will equal 60. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all, and that's what we call an outlier. So we know that these are going up in 2s, so this will be 28. So the x coordinate will be 28, and this will be 19. So our coordinate will be 28, 19 for our outlier. So when we say y is directly proportional to x, what we mean is whenever x doubles, y will double. Whenever x halves, y will halve. Now, we've got this proportionality sign here. And to make that an equals, all we need to do is introduce a k constant to the right-hand side. So it's y equals something times x. Now, to find out what that something is, to find out what that constant is, what we're going to do is feed in the value of y and the value of x that we have. So we're going to feed those in. So y is 55.3 and x is 7. So it would be 7k. And we're just going to put our lines in and solve this. So it's going to be divide by 7 both sides. And 55.3 divided by 7 is 7.9. And that's what k is. So we're going to rewrite this equation here, this formula here. Y equals 7.9x, and that is actually our answer. The formula for an exterior angle for a regular polygon is 360 divided by the amount of sides. Now here we're given the fact that the exterior angle is 30 and we're looking for n, so we just need to rearrange the equation. We can times both sides by n. And then divide both sides by 30. And so we've got n equals 360 divided by 30. And when you do 360 divided by 30, we get the answer of 12. So it's a 12-sided shape. So we're going to write an expression for the amount of people on the first bus. So they've started with X passengers and they've gone to 11 bus stops with X passengers. So altogether that is 12X. So we're going to have the first bus. And so we've got 12X. And then on the last bus stop, 19 passengers get on. So plus 19. Now for the second bus, well, we start with X and a further 5X come on. Because 5 bus stops with X passengers. So that's 6X altogether. And then 79 get on. And it says the first bus finishes with less passengers than the first. So the first bus finishes with less. And the way we show that is with this inequality here. Now all we need to do is solve that inequality. And we've got x on both sides, so we look at the x's. We've got 12x and 6x, so we always take away the smaller amount. So we're going to take away the 6x both sides. And next thing we're going to do is take away the 19 from both sides. And so, meant to be 60. Got ahead of myself. And the last thing we do is divide by 6 both sides. And so we've got x is less than 10. Now, it says here, assuming no passengers got off either bus, what is the largest value for x? Now, it is tempting to write down 10, but it says x has to be less than 10. So the biggest number we can get that is less than 10 is 9. The formula for the volume of a sphere is 4/3 pi r cubed. So we're going to do 4/3 times pi times the radius cubed, which is 17. And that gives us 20,579.526, blah, blah, blah. So to 2 decimal places, that would be 20,579.53. So what's happened here is that the company's increased the amount of sweets by 15%. So we're just going to focus on that and work out what the multiplier would be first. So they started off with 100%, and they added 15%, and then therefore they ended up with 115%. And to find that as a multiplier, we get the 115 and divide it by 100, and that gives us 1.15. So that is the multiplier they used. Now, they used that multiplier on the original amount, and they times it by 1.15, and they got the answer of 69. But if we're working the other way to find out what they times by 1.15, we get that 69, and we divide it by the multiplier. So if we want to work out what the original number was, we divide it by the multiplier, and that gives us 60. So the answer will be 60. The volume for a pyramid is 1/3 times the length times the width times the height for a square or rectangle based pyramid. And so we've got 1/3 times the 20 times the 20 times the 11, and that gives us 1466.666 recurring. And so to 2 decimal places, that is 1466.67 centimeters cubed. This question relies on the fact that you know what the equation of a circle is. The equation of a circle is x squared plus y squared equals r squared. Now, r is the radius of the circle. So, when I rewrite this, and I write it with our 16 there, we can actually rewrite 16 as 4 squared. Okay, comparing this equation to this equation, we can see that r is 4. Now, this equation, the x squared plus y squared equals r squared, gives a circle with the centre at 0, 0, at the origin. So, it means that the radius will be 4, so the circle will go all the way up here, all the way across here, all the way down here, and all the way across here. Now, I am really, really bad at drawing circles, and so what I would recommend you do is use a compass and measure out 4 and join these up. I'm going to try my best. I don't have a compass that works with this graphics tablet, but I'm going to try and draw somewhat of a circle. There we are. That's probably the best circle I'm going to draw. So what you do is you just get a compass and put the point at 0, and then you would measure out 4 units. So measure it between the 0 and the 4, and then just draw a perfect circle round. So we're going to start by finding the multiplier. So we start off with 100%. It says it's decreasing at a rate of 8.1%. So we're going to take away the 8.1%. And then when we do that, we get 91.5. 8.9%. Make that a multiplier by dividing it by 100, essentially making it a decimal. So whenever we get a number and we times it by 0.919, we're decreasing it by 8.1%. Now, there aren't any amounts given to us in this question, so we're just going to make one up. We're going to say that the population is 100, okay? And what we're going to do is type in 100 into our calculator, and then we're going to press the equals button. Now what that does is it stores the 100 in the calculator's memory. And it's basically, it's this next line that's the crucial bit. We're going to type in answer, which at the moment is that 100, times 0.919. And what that does is it says what the current answer is, we're going to decrease it by 8.1%. We're going to times it by that multiplier. And so every time we press the equals button, what it's going to do is it's just going to keep decreasing it by 8.1%. And we're going to count the amount of times we've got to press the equals button, because every time we press the equals button, it counts as a year. So when we first press it, it's going to be 91.9. Then press it again, it's going to be 84.4. So we're waiting for it to be beneath 43%. So if we started off with 100, we're looking for it to be below 43. So keep pressing it, keep pressing it. On the 9th year, we get 46.7, so that's close to that 43. Press it again, and we get 42.9. So it's 10 years. It's 10 times you've got to press it to get it beneath the 43. To find the length of the rectangle, what we're going to do is we're going to get the area and we're going to divide it by the width. Now, the question says that it wants the minimum length, so we want the length to be as small as possible. Obviously, to do that, we want the area to be as small as possible. If the area is smaller, the length will be smaller. But let's have a look at a couple of fractions. So let's have a look at a half and 1 over 100. Which one of those fractions is the smallest? Well, it's 1 over 100, but what do you notice about the denominator? That as the denominator gets bigger, the fraction gets smaller. So to make something smaller, we actually want the denominator to be as big as possible. So we want the width to be as large as possible. So we're going to find the lower bound of the area. And an easy way to find a lower bound is find the accuracy. Well, it says the accuracy is to the nearest 10. And what we're going to do is half that. So half of 10 is 5. And then we're going to take it away from the area. So it's 98,540, take away 5, which will be 98,535. Now for the width, we're going to do the same thing, half the accuracy, half of 10 is 5, but we're looking for the upper bound, we're looking for the biggest it can be. So we're going to add that on, 1, 2, 3, 5. And when you do that calculation, you get the answer of 79.78542, blah, blah. And it says it wants it to 4 decimal places. So we're going to do 79.7854. When we add fractions or integers and fractions, we need the denominators of the fractions to be the same. And when we've got an integer, we just convert it to a fraction. And here we've got 9k, and we need to convert that to a fraction that is over k plus 9. And the way we do that is we get the 9k and we times it by k plus 9 over k plus 9. And effectively, k plus 9 over k plus 9 is just 1. So we're doing 9k times 1. So we're keeping it the same. We're keeping it as 9k. So what we do when we times a 9k or a term by a fraction is we times the top, the numerator of the fraction. So it's going to be 9k brackets k plus 9. And all of that over k plus 9. Expanding the brackets, we get 9k squared plus 81k over k plus 9. And so what I'm going to do is just feed that back in here. And so we've got 9k squared plus 81k over k plus 9, which is just that 9k bit, plus 11 over k plus 9. And whenever we're in this situation here, we just add the numerators. So it's going to be 9k squared plus 81k plus 11, and all of that over k plus 9. And that will be our answer. So let's put that in our answer field. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got two radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagram as 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realizing is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got three of the sides, we can work out the last one. So angle DOB is going to be 360, take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360, take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360, take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference, and the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should really put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. Let's just put the 66 degrees on our diagram as well. And the final thing really here is that we've got a quadrilateral here, kind of arrowhead, and we've got three of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know, so the 228, the 13, and the 66. And the reason being the same as before, so angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. So we're asked to, first of all, complete the square. So that's what we're going to do. And to complete the square, we've got to remove the minus from the x squared because we've got to have x squared. So we're just going to factorize out the minus 1 effectively. We have minus x squared, and this has to be minus 10x. And then we're just going to leave the plus 7 on its own at the end there. The reason this is a minus 10x is a minus 1 times minus 10x is 10x. Okay, so we're going to leave that, and we're going to just focus on the x squared minus 10x. So the way we complete the square is you do a bracket, and you have x, and then you halve what the coefficient of the x is, so that'd be minus 5, and then square it. Now if you expand that, you get x squared, brilliant, minus 10x, fantastic, plus 25, right, we need to get rid of that 25. And so I'm going to now expand the bracket with the minus on. So we've got minus x minus 5 squared plus 25 plus 7. And then we're just going to add the 25 and the 7, and you should get 32. Now, if I'm to draw the graph of y equals minus x squared, it's just a graph that looks like this, but more importantly, that their maximum point on this graph is at 0, 0. And if we remember our graphic transformations say that if we have a minus 5 on the inside of our function, and so comparing this function, say this is f of x, part of this equation here involves a minus 5 inside the function. That minus 5 moves the graph to the right 5. Okay, so we're going to move it to the right 5. Similarly, if you have a function and you've got a plus 32 on the outside of it, which we have here, it's going to move it up 32. So instead of our maximum point being at 0, 0, it's moving to the right 5, so the x coordinate would be 5, and up 32, so the y coordinate would be 32. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.